Hello everybody, I'm Scotty from Scotty's Clock World. Thanks for joining me back on my channel. For today's episode, we'll assume you bought a clock at a collectibles fair or garage sale. You've taken it home, started to work on it, take it to pieces. You've taken out the barrels, and you've noticed that when you take the spring out, this one isn't, but we'll assume it is, you'll notice that it's broken halfway through. It's cracked through there. And you obviously can't use it. So, what are you going to do? If your spring is broken 3 or 4 inches in, that's not a problem. You can cut that piece of the spring off, punch new holes in here, set it up so that it looks exactly like that, and you'll be able to reuse that spring, and it will make no difference to the amount of time that the clock runs for. I'll be doing an episode on that quite soon, and I'll show you how to do that. However, if let's say your spring is broken halfway through, and if it has, you've probably also got broken teeth on some of the wheels in your movement, which you'll have to check. But if it's, let's say it's broken in here, if you throw that amount of spring out, cut a new hole in here, you'll have a 2.5 or 3 day clock, not a 7 or 8 day clock. So obviously you can't do that, though some people try to get away with that instead of buying a new spring, but that's totally not acceptable. Right, we'll assume we've got a broken spring and we've got to do something about it. So this is what we do once we've discovered we've got a broken spring. We have to work out the dimensions of the spring and the barrel and the arbor so that we can buy a new one from a clock parts supply house. And this is how we go about it. Before you order your new spring, there are 4 dimensions that you need to know. The spring height, the spring thickness, which is also called the strength, the arbor diameter, and the barrel diameter. You will need to know each one of those before you can select the correct spring. Alright, let's start off. Get our vernier out, set it to 0. First, we'll measure the spring height, which is that dimension there. $17.94 mils. We'll write that down. 17.94. Now the spring thickness. Check your vernier, make sure it's on 0 again. We want the thickness now. So that's the measurement we want. 0.44 mils. Jot that down. That's our first 2, that was pretty easy. Same as the rest. That's our winding arbor. We need the diameter of that, and that's measured across there. Make sure we've reset the vernier to 0. And that is the measurement we want. 9.47 mil. And the other measurement we need is the internal diameter of the barrel, which we measure like so, which is 44.97 mil. They are the dimensions we need to be able to buy the correct mainspring as a replacement for the broken one in our clock. When we go to Time Savers or Cousins or Meadows and Passmore or anyone else that supplies clock parts, Alright. We're looking at the Meadows and Passmore's clock mainspring length calculator found on their website. It's a very handy resource, and I'll explain more about it once we get into the video. You can see up here the formula they use to calculate the length of the spring. You can use that if you like, but it's a lot easier just to put it in their script down here. Barrel diameter is 45.1 mil. Arbor diameter is 9.5 mil. The spring thickness, which is also called the strength, is 0.45 mil. Hit the calculate now button, and up in the top right hand corner or the middle of the screen you get a message from Meadows and Passmore saying the length should be between 1357 and 1698 mil. That's the total length of the spring, and they suggest here, we'll close that out, they suggest here that you use at least 80% of the suggested length of the spring, but as long as it's between those two parameters, then it will work correctly in your clock. Alright, we placed our order, and a couple of weeks later one of those arrives in the mail. That's our replacement mainspring tied up with a very strong piece of wire. So what we've got to do is to get that mainspring into the barrel without damaging the mainspring or have it fly open on us. Right, so to do that, I'll start off with a stable platform here that I'll put the barrel on. That's the lug that this mainspring has to catch on. So we have a look and see. It obviously goes that way from the small to the wide, so that's the direction that it has to go in. You try to put it in the other way, it's not going to work, so it's got to go in that way. So we look for the widest part of the hole on the end of the spring. It's a hole end mainspring, of course, and place it just past the end of the lug here that it has to join, like so, on top. And that just sits there, and the wire sits around the outside of the barrel. Then take up a piece of wood. This is one I knocked up on my wood lathe, but any piece of wood will do. We place that over the top of the spring, and with a hammer start hammering down, not too hard, but hammering down on the block, and you'll see that the wire is moving up the side of the spring. I'll have to hammer that a little bit harder. There's a little bit of a dent in there, but we've got everything there in the correct position. Alright, hammer it again a bit more. You can see the spring is changing, or the wire on the spring is moving up further. So we shall continue. Everything's jumping up and down madly on my bench, but we're actually getting where we want to go. I think I'll take that outside and finish that off. The top of my bench is bouncing around all over the place. But as you can see, we've seriously moved the wire up. So I'll go outside on the back veranda, and on the railing there give it another couple of thumps and that should solve the problem. Then I'll be back. There we go, the balcony saved the day. The 4x2 didn't jump at all when I hammered that down. You can see now that the wire is right at the top of the spring, just holding it on the top there. So what we've got to do now is get the spring up here, which is slightly raised on a bevel, you can see. We have to get that down into the barrel, and then that piece of wire will pop off. Now to do that, you can use a piece of timber and hammer it down, but that takes a fair bit of doing because the end grain on the timber tends to open. So your best shot is to use a solid brass rod. Don't do what I saw someone doing the other day. Had a blade screwdriver. They put it in there and hammered the mainspring flat all the way around. Brilliant, brilliant operation actually. Every time he hit it with a hammer, he affected the integrity of the spring and caused micro chips and tears in each place around the circumference of the mainspring. And once the spring is wound up, runs down and then is wound up again, each of those will become a stress multiplier, and it's only a matter of time before one of them gives way and the spring explodes. Okay, so using our brass block, we line it up and tap it gently. On the outside lip and ring of the spring, and we've now removed the wire. However, if you look at that, you can see that the spring is still proud of the barrel. So we'll put our wooden block on it, give it a tap. That's just about got it down, a little bit more. Bench is still jumping around. So that's getting pretty close, but the cap has to go on the top there. And there's a little lip that's been machined into this barrel around there that the lip will sit on. And the spring is still proud of that, so we shall continue moving round, tapping the coils of the spring all the way around. And getting them to drop into place. Let's see if that's down sufficiently. It's right around there, but it's a bit high there. I'll try that a bit more. If not, it's back to the back balcony again, because that'll stop things bouncing. Let's see what we got. That's not looking too bad actually. I'll see if it's... Yeah, that may well fit in. Right, I'm going to test that in a moment. But before we do that, we've got to put our winding arbor in. So, align it so that the hook on that will catch on the internal of the spring and push it in. I think a key might help that somehow. It's a little bit tight, but we want it to be tight so it catches. Well, I get a key probably number 6. Nope. What's that? 8. Try number 8. No, maybe not. It's too big, but it'll allow us to push. That is tight. Now it's come through there all right, that's okay. Oh, you can hear the spring turning around in there. That's getting better. There we go. We've now got the spring wound up inside the barrel. The whole end of the spring is caught on the lug on the winding arbor. Right, now we're going to put the cap on. So I'll get a bench vise. This is an excellent little bench vise, this one in actual fact. Get that set up. Where are we? Down there. Right, straighten that up. I'll put that at a little bit of an angle, make it easier to see with that camera angle. What we're going to do now is you're going to put the cap on, make sure it's in the right orientation, place it between the jaws of the vise and wind it round, and then unwind it and keep your finger tight on the piece that you've just wound, because what we're doing is slowly pushing the cap down onto that little ridge that we looked at before. Not quite, getting close though. Right, the rubber jaws save any damage or any scratches and marks on the barrel. Right. Just about done. I think I heard it pop in then. Yep, that's got him. Nice and flush all the way around. Wound up. And there it is. That's how you do that. When one of these springs arrives with that piece of wire on it, you immediately think, how on earth am I going to get that out of there? That is the way it's done for a barrel mainspring. If you've got a loop end mainspring that doesn't sit in a barrel, it's done differently. I'll show you how to do that. I'll do an episode on that also. But there it is. That's that, and I've got 2 more to do, so I'll get onto those now.